company makes items A, B, and C, the construction process is split into 3 phases: parts, assembly, and finishing. The time in hours that it takes to complete each stage for each item is given in the table. If the company has 124 hours to devote to parts each week, 76 hours to devote to assembly, and 54 hours to devote to finishing, how many of each item should the company make to optimize profits? So with this information in the table, we can say that A is the number of item A that are made. B would be the number of item B, and C would be the number of item C. And the sum of the parts times is at most 124. So 2 times A plus 4 times B, since each item B takes 4 hours for this stage, plus 3 times item C is equal to the total time for parts construction of 124. And then we can do the same thing for the assembly, which should sum to 76 hours, 2 hours for each item. So 2A plus 2B plus 2C equals 76. And then the last equation, there are 54 hours to devote to finishing, with 1 hour for each item A, 1 hour for each item B, and 3 hours for each item C. So we could solve this using any of the methods of this section, so using matrices, using elimination, using substitution. Let's do elimination. And let's start by eliminating A. We can do that using these first 2 equations. If we multiply the second equation by a -1. Which just changes the sign of each term. Okay, add the equations together. A is eliminated. 4B minus 2B is 2B. 3C minus 2C is 1C. And then 124 minus 76. Okay, is 48. Now we also want to eliminate A from 2 other equations, so we just used equation 1 and 2. So now we need to use equation 3 with either 1 or 2. So let's use 3 and 1. So to eliminate A, we can keep the first equation as it is. And then the second equation, we're going to need to multiply it by -2 in order to get -2A. We multiply the whole equation by -2. So that's -2A, multiplying the B would be -2B, multiplying the C would be -3C, and then actually -6C, since we need to multiply it by -2, and then multiplying the last term would be -108. And then we add these 2 equations together. A's cancel, we get 2B minus 3C equals 16. And now we have these two variable equations in just B and C. So now we want to eliminate either B or C. Since we have 2B and 2B, it would be easier to eliminate B. So let's keep this equation, we'll call it equation 4 and equation 5. Let's keep equation 4 the same. So we'll just rewrite it. 2B plus C equals 48. Let's multiply equation 5 by a -1 to get -2B. And that changes the sign of the C to +3 and changes the 16 to a negative 16, so just changes the sign of each term in equation 5. Add them together, the b's cancel, and we get 4c. 48 minus 16 is 32. And now, this equation 6, we just solve that for c. So solving 4c equals 32, we would divide by 4 to get c is equal to 8. Okay, now that we know what c is, we can substitute back into equation 4. We could also use equation 5, either one is okay. So put c into equation 4. C equals 8, so substituting we get 2b plus 8 equals 48 by replacing c, and then we solve for b. So subtract 8 from both sides, get 2b equals 40. Divide by 2, we get b equals 20. We can use any of the 3 original equations, equations 1, 2, or 3, in order to find a. Equation 3 looks easiest to me, so let's plug in this value of b and this value of c into equation 3, which is 1a plus 1b plus 3c equals 54. So plugging in, we get 1a plus 1b, b is 20, plus 3 times c, and c is 8, so plus 24 equals 54. Combining terms, we get 1a, or just a, plus 44 equals 54. Subtract 44 from both sides to get that a is equal to 10. So what that means from this situation, the number of each item that should be made to optimize production, given these conditions, is 10 of item A, 20 of item B, and 8 of item C.